Pigs are very similar to humans in many respects in terms of their digestive system and nutrient requirements. And interestingly enough, their brain grows in a manner that's very similar to humans as well.
So from an anatomical perspective and the way that the brain develops, pigs and humans are very similar. So most of that growth of the brain is happening just late prenatal and early postnatal.
In humans and pigs, the brain growth spurt occurs a little bit before birth and a little bit after birth.
Between 4 and 9 weeks of age is a very critical time in the development of the brain for the pig, where we switch from a liquid diet to a solid diet. And this would then correlate to a specific age in humans, which would be about a 1 to 2 year old human, going from breast milk onto solid foods at that time.
One of the reasons why we're interested in the neonatal piglet is that it's a very good animal model for pediatric development. And what we wanted to do was expand on what's already known in the nutrition world to include brain development.
So we're really focusing only on one organ in the body, and that's the brain in this case. And we are looking at multiple ways of assessing structure and function in that brain.
Early nutrition and early life infection impact brain development and leave a fingerprint that may result in behavioral problems that manifest later in life. Developmental delays, lower IQ scores, attention deficit hyperactivity disorders, things of this nature.
What we're doing with MRI here specifically is building a brain atlas. So we're using this as another resource for us to use the pig as a model for human infants in this case.
The idea of the Piglet Brain Atlas was to create a tool that can be used by us and others in the biomedical community that have an interest in understanding issues surrounding brain development. When we started 3 years ago on this project, there were no sophisticated tools for using MRI in neonatal piglets.
The first couple studies that I started with, I sat at the computer and went through each image that we got and circled our regions of interest. And so that was a pretty labor-intensive process that took about 20 hours per pig.
And so we saw the potential to develop this neonatal piglet atlas that we can now use for what we're most interested in, and that's testing hypotheses.
Our animal facility is located in the South Campus, and from that facility we take an individual pig, put them into a transport device, transport them here to North Campus in the Beckman Institute. That pig is then brought down to this facility, the Biomedical Imaging Center, and awaits until it's its turn to go into the magnet.
So once we bring the animals to Beckman, we anesthetize them and we'll carry them into the MRI scanner room because we need to have the pigs be completely asleep because any kind of motion will give us bad images. Once they're anesthetized, we provide safety measures for the pig, including hearing protection, and we monitor their pulse rate and oxygen saturation. And we always wrap them in a warm blanket to make sure that they're comfortable during the scan.
So we literally have pigs in a blanket. So these scans run about 45 minutes long. We wake them up at the end of the MRI, take them back to their animal facility, and continue on with the study.
One of the things that is required to make a good MRI atlas is to have multiple image sets because each brain is going to be slightly different. And so for this, what we did is we took images from about 15 different piglets and we created an averaged brain.
And what it allows us to do is to take an individual animal, identify how it's different than our average brain atlas. That helps us with interpretation. We can look at more deeply how changes in the brain are occurring.
Now what we're able to do with the atlas is identify about 19 different brain structures, and it allows us a starting point for a lot of the more sophisticated analysis techniques.
Voxel-based morphometry, diffusion tensor imaging, MR spectroscopy. All of these things can be used to study brain development and hopefully extend that information to better understand issues that arise in human infants.
We are publishing all of the data on a website that other people across the world can go to and freely download all of the information. So it's kind of one common starting point for people that use the neonatal piglet.
We're really excited about this Pig Brain Atlas because we think it's going to be useful for many different projects. You know, we're interested in early nutrition, we're interested in maternal infection, we're interested in postnatal infection and how this affects brain development. But others across the world have different interests.
So with the ability to put a pig in a magnet in another research facility, they could use this atlas in order to derive more information for their own studies. And so we all come together as using the pig as a model in order to improve human health ultimately.